You probably use a knife every day, right? Cooking, filleting, a third thing. But do you know that you cannot, if you have a really, really sharp knife or a sharp blade, if you practice the blade, because you're both an angle and a demon, you can't see the sharpest blade edges. The sharpest blades on something like a really, really good kitchen knife or even a razor blade are on the order of microns thin. That's a millionth of a meter. And some of the sharpest are like 1 micron, which is the width of a human red blood cell. And you can't see the width of a human red blood. You can't see a single red blood cell when your blood comes out. So when you have a really, really sharp blade, you can see where the blade is coming to a point, but you can't actually see the edge with your naked eyes. So not only would you not see a ninja coming, you wouldn't even see the blade that did you in coming. These bad boys, which are coming apart right here, they are not very sharp. Freaking! But, no, they're just not very sharp. They're not sharp at all here. They're very sharp on the edge, on the end, because I already poked it through my hand. I could see near my bones. That was bad. So when you shave, you're shaving with invisible cutting edge is. Nailed it. Hello and welcome to another edition of Because Science Footnotes, the show where I take all of your comments, questions, and corrections about all of the nerdy stuff we get up to on the Because Science channel and address them so we can all get a little bit less wrong, which is my goal in life. Although I have realized that this show has just incentivized all of you to see how quickly you can find me wrong, which is a lot more stress on me personally than I anticipated that it would be. Pour caffeine on it! So on the last episode of Because Science, we tried to figure out if blocking bullets like Deadpool made any sense from a tactical standpoint. As we've seen in both Deadpool movies, Deadpool uses his katana, that's both singular and plural, as I've learned, to slice bullets in half that are coming towards him, and then the bullets follow the path of the blade and deflect away from his body and don't impact him. I came to the conclusion that if you had a wide enough blade, which is in the realm of possibility, and you had superhuman reflexes, then this would make kind of a viable tactic if you could pull off the moves to do so. But what did you have to say? Wow, there are over 1,800 comments across Because Science things at the time of this filming. That's maybe our most in the shortest amount of time. So you've been listening. Your chances to be on this show increase the faster you comment and the more that you comment. Except for a couple of you who are commenting like 10 times on something, I notice and exclude you. But for everyone who's having a bunch of awesome nerdy discussions in the YouTube and Facebook and Twitter and Instagram comments, keep it up. Awesome. Our first comment comes from Lightning Eagle. Can't afford the sound effect. Lightning Eagle 14, who says the only problem is that, as tests have shown, bullets don't always split perfectly into 2 equal halves. Sometimes there's 3 or more pieces of molten bullet that don't follow the perfect expected path. And Lightning Eagle 14, you're absolutely right. Bullet fragments, which are sometimes called shrapnel, incorrectly, shrapnel are pieces of a weapon that are intentionally sent out to do bodily harm to people. And shrapnel was the name of a guy, Henry Shrapnel. He made a weapon that sent out little ball bearings from an explosive to hurt people. Anyway, so they're not shrapnel, but bullet fragments do not split perfectly. What I try to do in episodes like these is reduce very complicated situations down to examples that we can actually put some numbers to. If we went through this rigorously, like did like temperature and phase change and for the molten metal and all these different physics calculations, I wouldn't be able to do one episode a week. So what I have to do is assume something very simple. And so I assume that there would just be 2 perfect bullet halves coming off of the sword. And that's what we see happen in Deadpool and Deadpool 2. So that's what I did. But you are right. When bullets fragment, it is not clean. It is very messy, and you have fragments going everywhere, which makes it even more dangerous, which is why you question if you want to split a bullet in half in the first place. You're totally right. Our next comment comes from 100 Hasake, maybe, I've heard it both ways, who says, so if Kylo Ren tried to slice a bullet, it would be a lot harder because of how wide he is. Don't laugh. But yes, I based the wideness coefficient, as I'm calling it, on my own body. And Ryan Reynolds and I are about the same size. He is about 4 or 5 times more handsome, but we're about the same size, so I based the wideness that we want to avoid on my wideness. Adam Driver, former Marine Adam Driver, is slightly wider, so you would extend what you want the katana shadow to be, which means that you'd want the initial angle on the sword to be wider so that by the time the fragments got to your wideness, they would miss your wideness. But it wouldn't help if Kylo Ren had a lightsaber, in fact, because one time in an episode of Because Science, we calculated that a bullet would only have enough time to melt as it traveled through the blade area of a lightsaber. And then it would be molten metal spraying onto Kylo Ren. And that explanation is actually canon now in a canon comic called Anakin and Obi-Wan, which you can see right here, in which bullets go through a lightsaber and melt into molten metal and get on Obi-Wan and kind of burn his cloak. So I'm so right. I love it. It never happens. Rarely happens. Our next comment comes from 2 people, Dragaz63 and Kurt Linder, who say some variation of, would there be a significant difference between getting shot by the actual bullet versus being hit by the bullet fragments, because there would be some energy loss when the bullet impacts the blade? Yes, you are absolutely right. There will be some momentum transfer between the bullet and the blade. I assumed it wouldn't be very much, but the bullet fragments would come off at a slower velocity from the blade. Now, those fragments could slow down to the point of non-lethality, but what I did is just assume that the halves could still be lethal. And if we do that, then it gives us a boundary condition. If we assume that the bullet halves can still be lethal, then it means that we need at least some value of angle so that those lethal pieces do not hit us. If those bullets then slow down at all, as they likely would in real life, then we have a factor of safety. And in engineering, you put in, like when you're building a bridge or a road, you put in factors of safety so that you're not exact, like this is exactly safe, because conditions change and the world is complicated. So you put in a slight factor of safety such that if something weird happens, people don't die. So I assumed lethality for these bullet halves so that we'd have at least a factor of safety if the bullets slow down. Better to be safe than full of holes. But at the time of this filming, the nerdiest comments I could find come from Khan's Pirate on Twitter and Ivan Stojanak, got close, on the YouTube page, who say, basically, it looks like in Deadpool 1 and 2, the bullets that he is splitting are coming at his head. And therefore, the katana shadow that you need doesn't have to be as wide as a full torso. And you're absolutely correct. In fact, when I was writing this, my friend turned around for a second, so I took my ruler and I measured how wide his head was without him knowing. And then I redid the calculations. And if you redo the calculations, assuming the distance away, but you only need a katana shadow that's the width of my friend's head, assuming it's an average head, then the blade angle on the katanas that Wade Wilson would use could go down into like the 15-degree range instead of the 45-degree range, which puts them close to the actual blade angles that katana have in real life. So if we look at that specific aspect of the bullet slicing scenes, then yes, this becomes even more plausible. So congratulations, you two are super nerds. That sounds kind of like the eagle from earlier. But of course, I'm not always right. Sometimes I'm just accidentally right. Like You know. So what did I get wrong this week? Our first correction comes from a number of people who all say some version of Deadpool would not have to have the reaction time that I calculated if he anticipated the bullet leaving Thanos' gun. And you are absolutely right. One of the commenters points out that Major League Baseball players cannot actually follow the baseball all the way to their bat because it is moving too quickly. So they train themselves to anticipate the ball and how it moves and start swinging before the ball even reaches their bat. So Deadpool, being a mercenary, being used to bullets being fired at him, would probably start moving his blade even before the bullet started moving in anticipation of the blocking motion that he wanted to use. So that means that he would have longer than just that 5 milliseconds because he could anticipate and move his blade into position before the bullet even approached him for slicing. So, yes, he could do that. And not only was I wrong about timing, I was also wrong about distance. Our next correction comes from Nicholas Harrison and Elliot Barth, who say some version of, were you accounting for how far outstretched both men's arms were when they were firing and blocking? I assumed that based on the heights of the two actors, Josh Brolin and Ryan Reynolds, that they were about 2 meters apart. And then I used that 2 meters to calculate how much reaction time Wade Wilson would need. However, I did not take into account how far outstretched Josh Brolin's arm would be when he fired that gun, which would reduce the distance by like 30%. I assumed in this, because I love to do the simplest version of everything, I assumed that basically Deadpool is blocking like this, but when the bullet gets there, he's like this, and then Josh Brolin is firing like this, directly at his chest, like pew, pew. I mean, you could do that if you were just doing it. Anyway, in Deadpool 2, you see him hold the gun out, completely outstretched arm, which would change the distance, which would change the reaction time and bring it down from a fruit fly's reaction time by quite a bit, but it's still in the same range. But even if you factor this change in reaction time in, it doesn't affect our blade angles. Something else does, though, that I'm wrong about. Our next correction comes from iGilly Production Z, who says, but a 9mm bullet is not 19 millimeters long, and it's too heavy. What I said is that a 9mm bullet, one of the most common bullets in the world, is about 9 grams and 19 millimeters long, and I used those values to calculate the cutting pressure at the edge of a katana to see if a katana could produce those pressures because of how the bullet's moving and slice through bullet material like copper and lead. And you're absolutely right, iGilly. I don't know why I got so confused, but when you actually look at a diagram of a 9mm bullet, you see that it's not 19 millimeters long, it's closer to 10, and they do not weigh around 9 grams. It's less than that, 7-ish grams. But if you change the values for the bullet, like in this correction, you do get a cutting pressure that's about the same. But if we want to be super, super nerdy about it, what you can do to estimate the force during an impact is to relate work done on an object to the change in kinetic energy on that object. If you want to be really back of the envelope about it, you can assume that something hits something else and comes to a complete stop, meaning that it's the change in kinetic energy is some value minus 0, and then you divide it by the distance over which it comes to a stop. This is what I did, but using the length of the bullet. So assuming it comes to a stop in its own length, like it's being crushed against a wall, which isn't quite accurate, right? The bullets continue to move after splitting. So if you want to get even more correction-y, you can assume that the change in kinetic energy, which Wolfram Alpha helped me out with quite a bit, say the bullet slows down when it impacts the blade from 350 meters per second to 200 meters per second. So still going pretty quick even after it gets split by the blade. Then, using the new values for the bullet in the correction, the cutting pressure goes down to 3 gigapascals again, which is what we initially had. All this is to say that we're still in the ballpark because of the quantities that are determining the pressure, the ballpark mass, the ballpark velocity, how much it's slowing down. You're still close to gigapascals of pressure, and that's way over the pressure that will overcome the material strength of bullets. And again, we know all this because we see them split on axes and katana and things like that. So, yeah, we could get way more analytical about all of this stuff. But again, I go for the easiest, most basic, hey, can you do this every week until you die approach. But you're correct. Our next correction comes from a lot of people who say 250 milliseconds is 50 times longer than 5 milliseconds, not 44 times longer as I wrote and said in the episode while using a calci-boy, or calculator if you're nasty. Now, you are correct that those numbers don't line up. But what you don't know is that on this show, I usually do quite a bit of rounding. It's easier to say something like 5 milliseconds than it is to say the true value that I got, which is around 5.6 milliseconds. And if you divide 250 by 5.6, you get about 44 times, which is what I wrote down. But I'm not being consistent in my rounding. Otherwise, it'd be exactly what you said. It'd be 50, not 44. So, thank you for keeping me honest. I need to be better at showing you or telling you when I round and when I do not. Otherwise, I'm just showing you values that are incorrect. And it's really embarrassing, especially when you have an old-fashioned TI-89 calci-boy, which is a workhorse. But the best correction at the time of this filming is kind of like the best comment, and it comes from Jack Frost and Ear Fritas, who say, well, Deadpool isn't holding his katana straight up and down, like I assumed. When he is swinging it, it is angled forward and out, which means that the blade is further away from his body than I assumed, because the tip or the cutting edge where the bullet impacts will be way out here instead of right here. And you're absolutely right, if you add just a single foot to the 2 feet of distance that I assumed, then it brings the cutting angle that you need, again, down to around 15 degrees, which is plausible for a cutting angle for katana, which makes this tactic even more viable again, which is super interesting to me. But the geometry is a little bit different because when you tilt a triangle downwards, the distance that the bullet travels is different, so the angles will be different. But that all goes to say that if the blade is further away, the bullet fragments have further to travel. And the further bullet fragments get to travel, the shallower the angle can be, because by the time they get to the same point that you don't want to hit, they will be further apart. It's kind of like why if you aim for the moon, but just change a few degrees because it's so far away, you could miss it. So, congratulations, Igor, and it's Igor. And Jack, you are both super nerds. I guess we're singing it. Now, if you are subscribed to Alpha at projectalpha.com, you already know what the next episode of Because Science is going to be, because you are getting premium Nerdist and Because Science content 2 days earlier than everyone else. But if you're not subscribed yet, the next episode of Because Science is going to be why Han Solo is wrong about hyperspace. That's right, just in time for the new Solo story, I'm going back to a very specific quote in A New Hope where Han Solo says, when Luke says, just jump to hyperspace, we gotta get away from the Empire, he says, this ain't like dusting crops. If you don't have precise calculations, you might fly right through a star or bounce too close to a supernova, and that will end your trip real quick, won't it? Will it, though? Do you actually need super precise calculations while jumping to or out of hyperspace? Is space really that dense? Will you have a good chance of hitting something if you pick a random direction and punch it? You'll have to watch this week to find out. So go watch the latest episode of Because Science if you haven't yet, and I will be taking your comments, questions, and corrections from those places at youtube.com/BecauseScience, facebook.com/BecauseScience, and @BecauseScience on Instagram and Twitter. And make sure to get in quick. I filmed this only a few hours after the new episode goes up, and there was already almost 2,000 comments that I had to go through, and I cannot go through all of those. I try to, so get in quick and get nerdy. And don't forget, sometimes I know it's hard to be in social situations because there's this crippling anxiety that you think that everyone is paying attention to everything that you do, whether it be good or bad, all the time. But that's not true. It can't be true. It's actually a psychological effect called the spotlight effect. We feel as though, because we are the center of our own lives, that people focus on us more than they actually are. But if you think about it, everyone is the center of their own lives, and so they're all thinking the same thing. But in reality, we don't usually put ourselves in other people's shoes and think about how their lives are progressing through space-time. And so what it comes down to is people are thinking about you and watching everything you do and judging you way less than you think. You can bring those stress levels way down, and it will help. One thing that I do now is just think about because it's very hard for me to be in public. So one thing that I do now is I think about the probability of me seeing any of these people ever again in my entire life. And I'm pretty sure it's fairly low. I'm pretty sure there's a lot of places that you go to that you see someone and you'll never see them again, ever. And so, if you trip a little bit, you stub your toe, you say something weird, it's fine. You're never gonna see them again. And they won't care, and you won't care. The spotlight effect is harder if you have a show where everyone's looking at you. Wow, there is a lot of hair down here. Go away.